Well, I guess it's time to start, because then we can finish. A couple of bargains I'm hoping to make with you. Don't have the whole class here, so hopefully the bargain will be easy. First of all, if enough people come back after the break, I'll get in early enough to get to the football game. I suspect everyone who's worried about that's already gone. Nevertheless, I'll do my best to start like maybe at 5:30, 5:35, somewhere in that range. Hopefully you can get there in time. The other bargain I'm going to try to make with you, I'm going to do it, is I put a homework up last night. It'll be due next Tuesday instead of next Thursday. And the reason is I'm going to cancel class next Thursday if you let me make the homework due on Tuesday. Otherwise, I'll have to find someone to come in here, sub for me, and put you through that again. But I'd rather just have the homework due on Tuesday rather than Thursday. It's not long, it's not hard. We've done everything we need to do it already. So I think you'll be all set. So next Thursday, we're not going to be able to have class. I'm going to be at the Dallas Fed. The reason I've been gone all these times, I went to the SF Fed, the Dallas Fed, the St. Louis Fed, the Chicago Fed. So I think that's it for the year for the Feds, for this quarter anyway. So that's that and that. Draw. So who's feeling lucky? I've randomized these, and all you have to do is pick a number between 1 and 7, and I will just, whatever number comes up. Okay. Just pick a number. Yeah. Okay. 1, 2, 3, 4. Oh, pretty good. What grade number 4? Draw. Yes. Homework. Yes. Thursday. Yes. I'm the only one that ever uses this board. Okay. So we have been using our short run, medium run model to analyze various changes. We've done monetary policy shocks, really LM curve shocks. We've done IS curve shocks, like government spending. We've done, those are the two things we've done so far. So we've done monetary policy and fiscal policy, changing the deficit and changing the money supply. We now want to use our models. Those are all the kinds of demand shocks. What makes up the demand curve? It's the IS and LM. And so there's IS shocks and LM shocks that can move the aggregate demand curve around. So we've done both of those with money supplies, the LM. The deficit stuff we did was the IS. Now we want to look at supply shocks, which are a little bit different. So how does our model react? How does our model predict the economy will react to a supply shock? So what we're going to look at, so we've done AD shocks, an M shock, or a budget shock. This was the money supply, or the LM curve. This was G or T, which was the IS curve. So we sort of shocked everything we can shock with an AD curve. Anything else that shocks those curves around, the graphs would be exactly the same. It's just a different driving factor. So now we want to look at aggregate supply shocks. And what we're going to look at is an increase in the price of oil, because that's a common supply shock that you see out there in the real world, and see how that increase in the price of oil affects the model. Now, the price of oil is not in our model. So how do we model it if it's not in our model? Well, we don't model it. So we need to add this to our model somehow. One thing we could do, so we've assumed just one factor of production. right? What we've been saying is y is a function of n. There's no capital, there's no raw materials, it's just labor. And that's a simplifying assumption. In fact, we've actually said that y equals n as a specific example of that. But more generally, you could say, well, y is a function of n, of capital, of raw materials, land. There's all sorts of inputs to production that we can imagine. And so one way we could handle the price of oil would be to add another variable to our production function and then complicate our production function to include that. Something like, n to the alpha, price of oil to the 1 minus alpha, or something like some model of the production. You might maybe have capital in there too, all sorts of things. But that's a possibility. That's probably the best way to do it, but it's also a hard way to do it. So we're going to take a shortcut. And we're going to model it as a change in the markup. We'll explain why in a second. So we have this equation that says price equals 1 plus the markup times the wage. Nobody's doing anything wrong, don't worry. I want to be able to see that, so I know it's working. So, we're going to say if the price of oil goes up with W constant, we need a higher price to cover the higher costs. Right? So we can model an oil price shock as an increase in the markup. For the same wage, when the price of oil is going up, we would need a higher price to cover the higher costs. So rather than adding explicitly to the production function, we're just going to model as a change in the markup over the wage. So when the price of oil goes up, you need a bigger markup to cover those extra costs. Right? Does that make sense? Cool. Then that means we're in good shape. Because now we can figure out how a change in the price of oil affects the aggregate supply curve. So we started off with this model. This is P0E F of U and Z. And then we had this line that was, this is P0 over 1 plus M0. And that gave us a mu, a U, an unemployment rate, a U, not U. So that's UN 0. In one natural rate. Remember, this model is a natural rate. We're at the natural rate. Let's assume that PE equals P for the moment. PE 0 means it equals P0. So we're at the natural rate because the expectations are correct. And we're just going to keep those constants. So we're at YN0, that natural rate of output for that oil price. And corresponding to this is a short run, so that's the medium run supply curve. There's a short run supply curve that depends upon that price expectation and other things. But I'll just note the price expectation for the moment. Then we want to ask the question, okay, there's an oil price shock. We're going to model as an increase in M. So an oil price shock probably should raise the unemployment rate, right? Just intuitively, and that's what happens here. You're going to get to P0 over 1 plus M1. That gives you a higher unemployment rate, UN1, and that's a new natural rate because the price expectations are still correct. We started off assuming that equaled that, PE0 equals P0, that was correct. The actual price and the expected price are the same. We haven't changed either P0 or PE0 at this point. So this must be a new natural rate, UN1. And it corresponds to a lower value. Now remember, this is P0 right here. So there's Y1N. What has to happen, pausing while you write, PhD students tell me to cover way more material than other people, so I'm trying to say. But it's clear things. If the expectation is correct, where does the short run supply curve have to intersect the long run? This point. What happens is this whole thing shifts to the left, including the short run supply curve moves with it. Because it has to go through, that's still PE0, it hasn't changed. It has to be correct at P0. So it must have shifted exactly like that. So an increase in the price of oil just takes this point and just shifts it that way. The whole, I was going to say kid and caboodle, but I hate that stupid statement. The whole thing. What is it? Is it? It's a real thing? Wow. I didn't know it was. What is it? A little makeup thing, I guess. Travel makeup kit. I don't know which came first, the caboodle or the kid. Someone look it up on Wikipedia really fast. Not supposed to have your cell phones. Yes, sir.
How come that array things with higher P, you need a higher P, and the P is constant?
High,
So you need a higher P to cover.
higher price to cover the higher price of oil.
So how come it stays constant?
We're just holding it constant. We're increasing the markup, but we just as a graphing. It doesn't necessarily stay constant. We have to have, if we had an aggregate demand curve on here, it maybe wouldn't in the short run. We're just using holding the price constant as a graphing device. That's why W has to go down. We have P equals 1 plus M times W. What we're doing in this case is we're just letting M go up, W goes down, as you can see, to keep P constant. And that's just a device. We want to hold price constant so we can see how this shifts. That's not going to be equilibrium necessarily. It will be in the long run. And don't mess up your graphs, but let me answer your question by drawing on this. So I'm going to do this later. But when I put my aggregate demand curve on here, what's going to happen here is this short run supply curve is going to have to shift up. And we're going to end up at a higher price level. So when we shift over here, it looks, oh, okay, we're not at the long run equilibrium, we're not the demand curve. And then So let's do that. The dynamics of adjustment is called. So we're just going to take the model, add the demand curve. Apparently, I think it's going to be complicated, so I'm making my job bigger. It's not that complicated. So we start off y, and I think I put the super and the subscripts in different places, but who cares? AD, short run, AS, E0, E0. We're at that point right there. So everything's wonderful, the economy's buzzing along, we're at full employment. People are just like ecstatic, no one has jobs at once. And then somebody raises the price of oil, so the Middle East goes into turmoil. And the price of oil shoots up. So this shifts back to y and 1, and this curve shifts right along with it. Short run AS, PE 0. The price expectation hasn't changed yet. So I'm going to call that point A. I'm going to use the same notation the book uses. I sort of misled you on that last graph a little bit on exactly where the shift's going to come from. The short run equilibrium that we'll end up at is right here. So call A prime. So A is the initial equilibrium. A prime is the short run equilibrium. At this point, price and expected price are no longer equal. So it must be a short run equilibrium. So in the short run, output falls a little bit, and prices go up a little bit, or a little bit, I mean, they both go up, not as much as they're going to. So at that point, we have an overheated economy, because the actual output's greater than the new natural rate. See that? So what will happen is the short run supply curve will begin shifting back as resource prices rise and price expectations rise along with it. Okay, right? So, and it'll shift back eventually until we get to this point. So here's price in the short run, and this is price in the medium run. I've just been calling that P1. So that's the new, and this is Y1 here. That's the new LL. So that's what the book calls A double prime. So A double prime is the medium run with the price expectations. This is the short run AS for PE1, because if we're correct, we're at the natural rate. So a supply shock shifts both the short run and long run supply curves in a particular direction. So if you've got a pretty steep demand curve, and this is the 70s, you get a big price in oil, you're going to get a lot of inflation as you make this adjustment.
You said supply shock shifts both short run and...
The medium run. I keep calling this the long run. The book calls it the medium run backwards. So yeah, both of those curves, this plus the vertical plus the slope one, both shift to the point. And you could do other types of supply shocks too. I won't do them, but productivity shocks and all sorts of things. If a given amount of labor, well, let's just leave this. We'll just leave it at the oil price shock. All right, that's that. That's chapter 7. Let's go over it. So now we're going to start chapter 8. probably going to skip chapter 9 for now on the financial crisis. I might save that. I'll decide. I'm probably going to go to chapter 10 after chapter 8. We will cover the financial crisis. I did some of those. Okay, chapter 4. This is on the Phillips curve. You ever heard that? I think I mentioned it. Natural rate of unemployment. And the inflation rate. Mostly it's about the Phillips curve. The other thing is sort of corollaries to that. Okay. So, what's the story? In 1958, I was 2 years old. I'd only be one until I was 51. This person called A.W. Phillips, surprise there, right? The Phillips group. So A.W. Phillips looked at British data from like 1861 through 1957, the year before, on the percentage change in wages and unemployment. So that triangle means changing. I think it's funny that you all don't mind triangles, but if I write dx, oh no. If I write triangle x, I'm totally happy. I never figured that out because it's the same thing. Anyway, so what are these triangles supposed to be? So you plot this, and it almost looks like it was artificially constructed. The data just, you put percentage change in wages here, and the unemployment rate here. And we didn't need econometric tools. The points really lined up in this amazingly consistent way. And you just drew a line through them, and that was called the Phillips curve. So it looked like there was this negative relationship between the percentage change in wages and the percentage and the unemployment rate. And that was called the Phillips curve. 2 years later, in 1960, Samuelson and Solow, 2 Nobel Prize winners. So in 1960, Paul Samuelson, and Solow, Robert Solow, both were at MIT at the time, used data from 1900 through 1960. This might have been 60 plus, it was late 60, but probably 61 if they used that data. The book said 2 years later, and I was just going with that. But that doesn't really add up. You can't write a paper in 1960 using 1960 data because it doesn't come out until 50 years older. In the early 60s, Samuelson and Solow, they looked at the percentage change in prices. We call that inflation, right? Percentage change in prices is inflation, and unemployment. And they did it for the U.S. And they got it wasn't quite as good, but they got a similar relationship for the U.S. They put unemployment there, inflation there, and it looks like there's this negative relationship between inflation and unemployment. Now, this seemed to be a permanent relationship. So at first, people thought it was a permanent relationship. Basically, we could have any unemployment rate we wanted if we were willing to accept the inflation rate that goes with it. So if you want 2% unemployment and you're willing to take 10% inflation, whatever it took, you can have it. You want higher unemployment, lower inflation, you can have that too. You can have any point on this curve, just have the Fed choose the inflation rate they want. You can read off the unemployment rate. And so people are saying things like our stabilization problems are over. We can fix the economy perfectly now. We'll just target the right inflation rate, and we'll get the right unemployment rate, and so on. But a funny thing happened on the way to the forum. So, in fact, if you look at the presidential debates in '60, they actually debate which point on the Phillips curve they ought to have. The Democrats are saying, we like low unemployment, we don't care about inflation because that hurts the rich, right? Republicans are saying, we care about this, we don't care so much about that. And so they're actually debating where on the Phillips curve you ought to end up. Then, so we're at some unemployment rate, some inflation rate. So the Democrats win and they start pushing up the inflation rate a little bit to kind of lower the unemployment rate. But suddenly, for the first time, this had never happened before, the points start going out here somewhere. In fact, we started getting up here. We got the inflation rate, we got the same old unemployment rate. And the response in 1960 was much like the response now. We didn't do enough stimulus. We need a bigger stimulus package. That was a problem. So they tried us again. Let's push. We didn't push this up far enough, so let's push it up again. They did. Then suddenly we started getting in this. This is like the 70s, then in the 80s. It's like the country's starting to shift out. It's very much puzzling. So you end up like at the end of the 70s, early 80s with this, the same old unemployment rate you started with, and so they successfully got the inflation thereafter, but the unemployment rate didn't change much. And so the question is then, what's going on in the data? How did this happen? How can we model it? All sorts of things. So let's talk about that. The book does this all pretty verbally. I'm going to try to add the graphs because I think that will. So I'll do that along with the rest. So we want to try to model this with the model we've used so far and see if we can understand what happened. Essentially, what the story is going to be is up until 1960, if you look at data for the U.S. or for Britain, the price level was pretty darn flat. The post-World War II period, there was a tiny bit of inflation. But, like in 1971, I remember my parents getting really, really upset because the inflation rate was like 2.5%. People just weren't used to inflation then. It was zero for their whole lives until 1960, 1970. So what the story is going to be that these are associated with different price expectations, different inflation expectations. And that the initial Phillips curve was really a Phillips curve where people had a fixed price expectation, inflation expectation of zero. Once you actually, so you start off with essentially zero inflation. Once you give people inflation, it changes their expectations. When it changes their expectations, this thing shifts. And so when the expectations are correct, it can be at the natural rate. And then so they try to push it up further. The more you surprise people and their expectations are wrong, it matters. But the minute they adjust their expectations, it's going to shift again. So it's going to be an expectations adjusted story in the end. So that's what we're after to try to explain it. And start understanding about rational and adaptive expectations and how expectations fit into the model. Because expectations play an important role in modern models. So we can start with P equals PE and 1 plus times F of Z. This is the equation of the AS curve that we derived in the previous class. I want to say last class, might have been the class before that, I don't know. But at some point we said that's the aggregate supply curve. It's just the wage and the price equations put together. You just eliminate W from the wage and price equations to get this. You take P equals 1 plus M times W, and W equals PEF of U and Z. and just plug that there. So that's the AS curve. All right. Now, it's convenient to adopt a specific model of F. So we're going to adopt a specific model of F of U and Z. We're going to assume a very simple form. It's 1 minus alpha U plus Z. So F depends positively on Z, negatively on U, just like always. So simple. So now we have that P equals PE, and 1 plus M times 1 minus alpha U plus Z. And that's chosen so that the next step works well. The appendix, we're not going to do this, shows this is well approximated by, so you can approximate that relationship by the following. Pi equals pi E plus M minus Z minus alpha. That's the supply curve. That's our modeled supply. It's just an approximation of this. Basically, if you've had any math, you take the log through here, it separates these terms by taking the log. Then you say the log of 1 plus m is approximately equal to m for m is small. And so you approximate these things by using, that's how you get this term and this term. Anyway, so you just use approximation. There's tricks that you can use for logs. If m is small, the log of 1 plus m is approximately m. So it's based upon those sorts of things. But don't worry about it. It's easy to get this if you know how to do it. If you don't, it's hard as hell. That's hard.
Is it M minus Z or M plus Z?
That's m minus, let me make sure I've written it down many times. Oh. Every other time I write it down, it's plus Z. Thank you. You must have your book on it.
Yeah.
Thank you. I don't know what I did there. If you're going to make a mistake, a minus for a plus is better than a plus for a minus. That's going to be our Phillips curve. It's a relationship between inflation and unemployment. And pi e 0, it's a permanent relationship. So in essence, what we have here is a relationship between the unemployment rate. The book doesn't do this, I don't know why. The inflation rate. And it's easy to, what's the slope? There's a big hand. Minus alpha. And what's the intercept? Pi e plus m plus c. So what you have is a negatively, I guess it's either a straight line. So this is the Phillips curve. The slope is minus alpha, and this intercept up here is m plus z pi e plus m plus z. Yes. But we've approximated something. Technically, this is a straight line, but it's an approximation to a nonlinear relationship, and so graphing it's not going to matter how you technically, yeah, we have a straight line. So it will shift up if what? E goes up, M goes up, or Z goes up. This is what we're after. That's going to be the key in understanding why the Phillips curve relationship broke down in the 1970s. And so I think if the book just would have drawn this graph, they make that really simple. Instead, they do these verbal points explaining how this curve shifts if these things change. I think it's trivial to see. It shifts 1 to 1 with expected inflation. Expected inflation goes up by 2. This will shift up by 2. So the vertical shift is 1 to 1 with expected inflation. Okay, so let's just be more explicit about the story we've been telling. I wish I had Fred with me. I didn't with my computer. I can do it on my iPhone. It's a Fred app. Fred's Federal Reserve economic data. It's a great place to get macro data. I can pull up the price level for the U.S. since about 1900. And what you'll see for the U.S. is it sort of looks like over time, there's the Great Depression. It's pretty flat. Here's World War II. Then it starts to go up a little bit. And then you get to the 70s and you get an acceleration, and then it sort of levels off after that. But up until, say, about 1960, it's reasonable to assert that inflation expectations were 0. People just didn't expect inflation. There was no such thing, for instance, as a variable interest rate loan. Those came about in the 70s after the banks got screwed by having fixed interest rates and high inflation. Then no one even thought at this time you needed a financial asset whose interest rate would vary with the rate of inflation. But then they did. And so up until 1960, very little inflation. Reasonable to assume that the expected inflation rate is a big goose egg, or 0. And that's the relationship they estimated. So that's what Phillips, Solow, and Samuelson were estimating, was a Phillips curve where the expectation was 0. So they were looking at pi t equals m plus z minus alpha u. So they had a Phillips curve, unemployment, inflation. But this was just m plus z because pi e was 0. Now, they don't know that the inflation expectation belongs in there. Friedman and Phelps are going to try to warn them about this, but they don't know. All the theory that tells us why this happened is developed later. So they estimate this thing. They don't really think about this part of it, but that's the even important thing to think about. You see, they thought it was a permanent relationship. Even if you would have put this in your regression, you'd have gotten a 0 coefficient because it just wasn't moving around. And so there would have even been no evidence that it belonged in there. So unless you knew theoretically that this was important, you're going to miss that that belongs in your So it breaks down in the 70s. So that relationship, that so-called permanent relationship, breaks down in the 1970s. Got my driver's license at 72. Next year, oil prices just shut the hell up. It's no longer a quarter a gallon. What would that be today? Not that much. Probably double twice maybe. 40, maybe 3 times, now twice. Maybe $1. Why? Well, wage setters, people, why? One reason was the price of oil shot up, and that caused inflation. But that's not the main reason. What that really does is shift the natural rate around. It doesn't really have a long-run effect on inflation. People changed their price expectations. So inflation goes up in the 70s. My mom and dad are complaining in 71 about 2 to 3%, and then it goes way, way above that, and they're really pissed. And so that causes price expectations to go up. Partly was a misapplication of Keynesian economics. In some sense, we can, not some sense, we can think of this as a breakdown in Keynesian model. Keynesian economics is really good at dealing with demand shocks. It's not so good at dealing with supply shocks. And so if output goes down because of a supply shock, negative supply shock, that's going to drive prices up. And if you try to solve that by pushing demand up, you're going to create more inflation. It's not really the right solution to that problem. They didn't know that. And so they kept trying to attack these oil price shocks, these supply shocks, with demand-side tools by pushing inflation up, which is the way you would cure a recession if it was a demand shock. And what that does is just gives you more inflation. It doesn't really help a lot. And so we have this misapplication of the Keynesian tools causing lots and lots of inflation, and not much to show for it, to be honest. And that causes people to change so that they perform their expectations. So we can model this too. Before the 70s, it looks like people have a price expectation that's just equal to yesterday's price. Whatever yesterday's price was, that's what I think it's going to be today. Now, that has a specific implication because inflation expectations are just the difference between the expected price tomorrow. At the beginning of time t, you don't know this. So that's your expected inflation rate over the time t period. It's how much prices go up over the last period. And so, this is in logs, I should have said that anyway. This is the way you get inflation expectations in this model. So if that's true, we're starting off in a world where price expectations are essentially, or inflation expectations are essentially zero. So in the initial Phillips curve, you have people setting expectations in this way. Now it looks like, but they're wrong year after year. This is what we call adaptive expectations. So I wrote a column that had this story in it earlier this week for the Fiscal Times. I was talking about rationality and the Nobel Prize. So let me use this expectation mechanism. Here's what you could do with a little kid. Like you play a tickle game. Where you tickle their knee and then tickle their armpit, tickle their knee and tickle their armpit. If they form this expectations mechanism, this is the tickle spot we're trying to guess. If they guess the last one, what's going to happen? So I tickle here and they say, okay, where do I expect it? Oh, I expect here. Then you tickle the knee. Okay, that's wrong. Okay, I expect here. Even a 2-year-old is not going to get fooled like that forever, right? They're going to quickly adapt their expectations if they're getting fooled time after time after time after time. they're gonna realize what the rule you're using. Oh, it's high, low, high, low, high, low, I should cover up that way. And the only way you're gonna tickle them is only surprise tickling would matter. You know? So you fade low and do too high, low, too high, low. Then they figure that rule out. So we're going to get this result later that's exactly like that. When people understand the nature of the game and the policy rule that's in place, you get what's called monetary neutrality. But the main point for now is that if people are consistently making errors, they'll update their expectations. They'll change them in a way that stops them from getting hurt or tickled, whatever it is. If you're a wage earner, bargaining over your wages, and you expect no inflation, okay, I don't expect any inflation, so I want the same wage I had yesterday. That's what this really says. Okay, oh shoot, there was 10% inflation this year, now it's time to bargain again. Okay, I want the same wage I had last year. Oh shoot, there was 10% inflation, I should have asked for a 10% raise. Okay, I want the same wage I had last year. Oh no, you're not going to keep making that mistake and getting hurt year after year after year. Eventually you're going to anticipate the inflation. This model of expectation says I can fool you with inflation year after year after year and cause you to have lower than the wages you thought you were going to get. And workers are just not going to keep making that kind of mistake. So they'll eventually begin to anticipate the inflation. So in the 70s, it looks like they adopted something like PPT is theta pi t minus 1. Excuse me. Now they start to expect inflation. This expectation of inflation is no longer zero, but it's something. And it's some fraction of the inflation rate you saw last year. Now, theta could be 1. It could be exactly the inflation rate you expected last year. In this model, you're not going to be able to surprise people with price shocks. They're going to anticipate them. And so, we can think of this as before the 70s, theta was 0. This expectation was 0. After 70s, theta is greater than 0. It's some positive numbers. By mid-70s, the evidence suggests theta equals 1. So expectations are moving 1 to 1. Past inflation. So now if you're that worker, you're not going to get fooled. If there was 10% inflation yesterday, you're going to expect it. So now you're going to, they could fool you with the higher or lower level of inflation, but you're at least going to expect what you got last period, where in the other model you weren't. Okay, well. So now we can take our model, pi t e plus m plus c alpha u, and rewrite it as pi t is theta pi t minus 1 plus m plus z minus alpha u. So that's a pretty good model of the Phillips curve of the economy after 1970. And then when theta equals 1 after the mid-70s, often just write this way. So this is the change in the inflation rate. So this is delta pi. This is the change in the inflation rate. So it says that the change in the inflation rate, if unemployment goes up, inflation will fall. If unemployment goes down, inflation will go up. So you get a positive or a negative change in inflation with every change in the unemployment rate. So this goes up, the change in inflation goes down. So this implies U up leads to decreasing we call disinflation when it crosses 0. Do you know the terminology? When inflation is going up, it's called inflation. When it's going down, if it's above zero, we call it disinflation. If it's below zero, we call it deflation. So deflation means negative inflation, whereas disinflation means like 5 to 4. So and when U goes up, oh, I see. It's going to be the same case. It should be different. When U goes down, you get increase. And we'll do something this a little while later. If you take data from 1970 to 2010, I really don't like that sample period because it includes the Great Recession, and the Phillips curve tends to break down in the Great Recession. I really, really, really wish they would ended this in 2007 because it probably biases their estimates. Because we're going to argue later the Phillips curve breaks down in great big recessions. So why include that in your estimate? Anyway, they did. Pi t minus pi t minus 1 equals 3.3% minus 0.55 ut. So if you take this model to the data, there's actually a graph of that in the text. I didn't bring it. You'll get that estimate. But again, I kind of wish you tend to see points off the Phillips curve, even the shifting line when you get into Great Recession. So, look at this. So when unemployment goes up by 1%, what happens to inflation? It goes down by about 0.5%, 0.55%. If I want a 1% change in inflation, how much does unemployment have to change? 1 over 0.55, or about 1.8%. So it's about a 2-to-1 trade-off, according to this model. That's not good, right? It takes a 2% change here to bring this down from 1. What if you had a 10% inflation rate and you want to bring it to 6? How much would unemployment have to go up? Like 8%. Just to drop this 4%. That's a huge cost of inflation in terms of unemployment. We'll come back to that question later. Okay, let's go on to the Phillips curve. And the natural rate of unemployment. It's really, we can use this to estimate and derive the natural rate of unemployment. Okay, so remember that the original Phillips curve implied a permanent trade-off between inflation and unemployment. Milton Friedman and Phelps in the late 60s argued that if the government tried to exploit the trade-off, it would disappear. That it wasn't permanent. One of the things that made Friedman so famous is predicting this in advance. That shifting Phillips curve, he saw it coming. It's going to shift on you if you try to push up. Then when it actually did shift, everyone said, oh, these people in Chicago are pretty smart. We should follow them. Okay, so all right, I'm gonna try to exploit the trade-off. Leaving the O off trade-off, it would disappear. And you return to the natural rate. NR's natural rate. So what were they talking about? So let's derive most economists sort of accept what they said. So this was a prediction. What were they saying? Remember, our model is pi t equals pi te plus m plus z minus alpha u. So that's just our supply curve approximated. Now, in the medium run, what do we know? Expectations are correct and at the natural rate. So by definition, we've defined the natural rate to be the unemployment or output or whatever that exists when expectations are correct, right? So we could use that. 0 equals, if I bring this to the other side and they're correct, well, I can do it this way. Pi t equals pi t, because it's correct, plus m plus z minus alpha u. Those cancel. You get alpha u equals m plus z. So you get that the natural rate of unemployment, un, is just m plus z over alpha. See that? So I'll do one more little thing here and then this break. So we can rewrite the Phillips curve as pi t equals pi te minus alpha times ut minus m plus z over alpha. The alphas, that just gives me the m plus z we had before. You see, do I multiply those out? But this is un. So now, with a little bit of theory and thinking, we see that the difference between inflation and expected inflation is related to the difference between unemployment and the natural rate. And what Friedman and others were saying is that when this equals this, that has to equal that. You're at the natural rate when the expectations are correct. And so people adjust their expectations. If this is fixed and you raise this, you can raise the unemployment rate. This will be positive. But as long as these are equal, the only way this is going to be 0 is if those are equal. And so when expectations are correct in the medium run, you're going to return to the natural rate. Anyway, so the deal was, if enough people come back, instead of going to the football game after break, I'll end early enough for you to get there. So let's break. Or I could just go straight through until like 5:25. Want to do that? I was going to go until 5:30, but if we skip a 5-minute break. Let's do that. Yeah, it's fine. All right, so let's keep going. Yes.
So you can write it as the first equation, and the arrow that points down at UN, what does that signify?
That this is equal to, we just showed that UN was equal to this.
Yeah.
So I'm just telling you why I'm going to do this.
UN is unemployment.
Natural rate of unemployment. So it's saying that deviations of unemployment for the natural rate are related to deviations. Maybe I should have written it as pi t minus pi t equals minus alpha times u minus un. So any deviation here has to be matched by a deviation here. Good thing about not having many people here is when they do leave, I know who they are. I'm whining later about their grades. Sorry. The two-sided effort. I want to see it too. And then this is pi t minus 1, or pi t e is theta equals 1. So we can put that in. Now, if you remember a few minutes ago, we said that pi t minus pi te is equal to 3.3% minus 0.55 times u, right? At the natural rate, by definition, that must be true. So that tells us this is 0. So 0.55 u equals 3.3%. So the natural rate estimate for the US, that turned out to be exactly 6%. So if you use this model to estimate the natural rate of unemployment for the US from 1970 through 2010, you'll get 6%. If you leave out 2007 through 2010, I have a feeling that might be a little bit lower. Starting with 70 isn't great either because you have a big shock in 73. Anyway, yes?
So why is that 0?
Because these are equal. So at the natural rate, the natural rate is defined as expectations are correct. So if that equals that, that's 0. Okay? So the definition of the natural rate is expectations are correct. It's not the only possible definition, it's the one they use in this book. This is not in the book. Let's just see if we can use this model. So they estimate this original Phillips curve, which has expected inflation 0. Over here somewhere is 0. So this must be the natural rate in our model right here. That line is the natural. Sometimes we call that the long run Phillips curve. This book would call it the medium run Phillips curve. And sometimes this is called the short run Phillips curve. So there's a short run and a long run. And the long run and the medium run is when expectations are correct. That's what we had so far. So it's reasonable to think what we were seeing in the data up until 1970, this era where there was no inflation, was sometimes there'd be a little bit of inflation on both sides. In the Great Depression, there was a big spike downward. Sometimes it'll go upward. And you're really just mapping points along this line based upon this expectation that inflation was zero. And as long as on average that was actually true, there was no reason people change their expectations, this curve was stationary. So sometimes you're down here, sometimes you're up here, but on average you sort of have a zero inflation. Then in the 60s, and particularly in the 70s, it was even worse. They began trying to target points like this. So let's have an inflation of 3-4%, something like that, lower the unemployment rate. Now, one reason they did that was that there was an error in their assumption about what the natural rate was. In the 1970s, we had a lot of baby boomers hitting for the first time. We had women entering the labor force in record numbers. And new workers, it's nothing about quality, but new workers tend to change jobs a lot. Oh, I want to be an accountant. I go through the business school, I go out, I'm an accountant for a year. Geez, this is what I thought I was going to be. I want to do anything else in the world for this. So you see a lot of people changing jobs early in their career, then they settle in, they don't change as much. So we have a lot of new entrants in the labor force. You get a lot of frictional unemployment, a lot of natural turnover. So we saw a lot of friction. That raises the natural rate a little bit. We also had a lot of structural change going on in the economy at that time. That also raises the natural rate. Oil price shocks raise the natural rate. We saw that earlier. And so they didn't really understand that the natural rate of unemployment might be, say, 7% in the 70s. And they said, we need to hit 4%. And so the policymakers said, we got to do something. We're above target. Well, our Keynesian tools tell us what you do is you start pumping money or government spending into the economy to try to get demand up. So they diagnose this as the unemployment rate's too high because there's deficient demand in the economy. And so let's pump some money in. So they do. So they create this inflation. And at first it looks like it's working. Wow, unemployment falls. Great, yay, yoo-hoo, it works. And then, as we said, once our parents, or maybe grandparents, started saying, oh no, I've never seen inflation before in my life. It looks like we're in a new world now where inflation matters. And they really did do that. Expectations changed and this curve shifts. Phillips curve for PE equals pi 1. This one. That's what you're correct. And so you go from A to B to C. And then policymakers say, oh, damn. We didn't do enough policy, clearly, because the unemployment rate's still too high. This is what a lot of people are worried about right now. We're making the same mistake. There's a big fight over the natural rate of unemployment. Some people are saying the natural rate of unemployment is 7%. We're at an unemployment rate of 7.2. There's nothing for the Fed to do. If they try to do anything, it will be highly inflationary. Other people say, no, the natural rate's 5%. We've got a 2.2% gap. That's huge. We need to attack this aggressively. So depending upon your notion of where the natural rate is, will give you a sense about how aggressive your policy should be. Well, they're worried we're making the same mistake. We think the natural rate is 5.5, or 5%, or 4%, but really it's 7. And we're going to shoot at the wrong target. QE, all this is going to pump a bunch of money in, and we're going to end up with a 1970s problem. So there's been a bunch of Fed presidents saying, Plosser for one, Philadelphia, the Dallas guy, where I'm going next week. I should speak softly into the camera right now. They've been warning about this and opposed to QE and voting against it and all sorts of things. Esther George at Boston is in a similar camp. And actually, Plosser just apologized and said, I think I've been wrong. We haven't seen the inflation. This model seems to break down for some reason in recessions, and we'll talk about that why later. But we haven't really seen the inflation that all these people have been warning about. Now, some of them are still saying it's just around the corner, we just haven't seen it yet. This is the guy making that argument, just made it the other day. Anyway. What they did, though, is try this again, essentially. So pump the inflation rate up to pi 2. People change their expectations again, and the Phillips curve shifts again. Now suddenly we're sitting up here with inflation rates in the teens and high unemployment relative to history, and people are just putting their hands up on, our models just totally messed us up here. Something went wrong, we don't understand this. And that's when they went back and developed all this theory to try to understand what the hell happened that got them into this box. Because we're going to talk a minute about what we have to do to get out of this. So how do you get out of this box? And I'll write all this down again in a minute. Let me just pick it up the bigger picture here. So now you're stuck up here, and you want to bring, let's say you want to bring inflation. You're Paul Volcker in 1979. You're facing an inflation rate in the teens, and you want to bring the inflation rate down. If you've got credibility as the Fed, you can change people's expectations immediately. So if you're credible and you say something, you know, if you haven't been lying to your family your whole life, they're going to believe you when you tell them something. So if you have credibility and we say, okay, we're going to lower the inflation rate from this high rate we have now, pi 2, to pi 1. If people's expectations change the minute you say that, this curve will shift and you'll sort of go from this point from here to here. Because expectations will change immediately. It won't be very costly. You won't have to hardly pay any unemployment costs to bring down the inflation rate if you have Fed and if you have credibility. That's why the Fed is so worried about its credibility these days and making sure it does what it says and it makes a promise and keeps it and it tells us what they're going to do and they tell us again and they try to do exactly what they say. Because they're worried that the minute they lose their credibility, the following happens. If you want to bring the inflation rate down and you don't have credibility, you have to be from the show me state, right? You have to actually move out to this point. Because what happened before 79 is a bunch of Fed presidents said, we're going to take care of the inflation rate next year. We're going to bring it down. And the next year it'll be higher. This year we're really serious. We're going to attack the inflation rate problem, and it's going to come down. It's going to be even higher. So Volcker comes up and says, I'm bigger than they were, big tall guy. And I'm serious, and I'm going to bring it down. Nobody believed him. Yeah. He's another Fed president. Tell us what we want to hear. But he did bring it down. He raised interest rates and brought the inflation rate down. What happened is we moved out to a point like this. We had to pay a great big cost. The unemployment rate in '82 shot up to nearly 10% as they tried to fight inflation. Then, now we get Volcker, he had whatever to do this, and he stayed with the policy. He didn't care if it was all this costly. That's why we have an independent Fed. No politician could have ever done this, tolerated this high, 10% unemployment rate. They'd been thrown out of office. But Volcker, he did it. He didn't care what the public thought about him. Now he's a hero. Blah, 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 blah. Eventually, people said, oh, yeah, gosh, this Fed president did what he said he was going to do. And we got to hear. Then the next time, it was easier. Not everyone believed you, but, if some do, it kind of shifts it down, and then you move like that. And so if the Fed has credibility, you can move the inflation rate around without paying much of an unemployment cost. If the Fed does not have credibility, then potentially, depends on the shape of this curve. If it's steep, it's not going to be so bad. But we think it's pretty flat. So then you got to pay a pretty big cost in unemployment in order to bring down the inflation rate. So it seems like that's the story that happened. We discovered this thing, we tried to exploit it. Friedman and Phillips said, hey, if you try to exploit this thing, it's going to shift. I think it was Friedman an AEA presidential address in '67 or something like that. And it shifts. Oh, we didn't do enough. Shifts again. Oh, we're stuck here. We have no credibility. What do? We're just going to take the hard way out. Reestablish our credibility by doing what we've said we're going to do finally. And now we've got a world where it looks like the Fed has, when they say, in fact, it seems like their credibility has almost backfired on them in this recession because it actually wanted to raise the inflation rate a little bit. It would be helpful. If you could raise the inflation rate right now, it would be stimulative. But they haven't been able to move long-run inflation expectations off 2% no matter what they've said. So it seems as though the public says, we don't care what you say. We believe that you're going to target a 2% inflation rate in the long run. You can tell us anything you want, but that's what you're going to do. And it's been really hard to change people's inflationary expectations recently. Anyway, so that's that. So that's a pretty good story of how the world has worked. we're probably, one of these, 2% here. We're way out here on some of those curve right now. High unemployment. Let me do one more thing. I'm writing books headers. The neutrality of money revisited. So you remember what neutrality means? What's neutrality of money mean? It actually wasn't before. It means a change in the money supply has no effect on real variables such as output and unemployment, right? So when money's neutral, an expected change in the money supply has no effect on anything we care about, like real output and unemployment. Now we want to see about money growth. We said earlier that the AD curve can be represented as y is some function of m over p g and t plus minus. So that's just a model of a standard AD curve that depends on m over p, g, and t. Nothing new. So let's look at the medium line. When inflation expectations are correct, U equals UN and Y equals YN, or at the natural rate. So I can write that as YN equals some function of M over P, G, and T. If we hold G and T constant and stay at YN, the natural rate, if money growth equals mg, just as a money growth is denoted, is it mg? GM, the growth of money. GM. So that's the money growth rate, like 3% growth of the money supply. What must inflation be? If everything in this equation is fixed except these two variables, if this is growing at 5%, what's this have to do? It has to grow at exactly the same rate. If this doubles, what's this have to do? It has to double. If this goes up by 10%, this has to go up by 10%. So, must be that pi equals GM. So in the medium run, inflation is equal to the growth rate of the money supply. Nothing else. So this was the basis of Friedman's famous statement saying that inflation is always and everywhere a monetary phenomenon. The reason we have inflation is money, plainly, money growth, plainly instantaneous. Doesn't depend on anything. Price of oil, none of that stuff matters. Only that matters is the money growth. Basically, you have this aggregate demand, short run AS, medium run AS. If money's growing at a fixed rate, and I need to stay along this line, the price has to grow at the same rate that money's growing. And this curve's shifting out at some rate, this has to shift up at the same rate. So you get that money growth, inflation must be the same. Prices will grow as this shifts out. And you get that relationship. The medium run. In the short run, other things matter. Price, oil price shock, government spending shocks, all those kinds of things in the short run can impact the inflation rate. In the medium run, it's simply the money growth rate.
Earlier we said was Fed things are fairly good and going way down. Like they just like get like a study up to get unemployment down because only
An increase in government spending would lower the unemployment rate in our model, theoretically. But the problem with that is the Fed does not control government spending. That's Congress and the President. So in the last FOMC press release, one of the statements was basically fiscal policy is a drag on the economy that's making our job harder. Every speech that Ben Bernanke has given over the last year or two has implored fiscal policymakers to help the Fed out and to quit doing this austerity stuff that makes their job harder, not easier. But the Fed has no power, and it would be a mistake for the Fed to begin acting in a way that looked like they were behaving politically, because there's all too many people in Congress who would just love right now to take their independence away. And so they begin to look like they're taking a political position on what the size of government should be, or any of those kinds of questions, and they're going to endanger their independence. So I think what the Fed ought to do, they don't always do that, is talk about fiscal policy only in the sense that it impacts monetary policy. If you don't get your stuff together, it's going to force us to do the following. And if you do this, we're going to do that. That's not political. That's just saying if then, if then, if then. They're going to be forced into this position. But they're very careful not to be politically motivated. Well, I promised I'd stop in 15 seconds. And so I'm going to keep that promise so that I have credibility for the future.